Good evening everyone. Welcome to Gate Academy Global. If my audio and video both are perfect, then just confirm me. Just confirm me my audio and video both are perfect or not. So as you can see, just first confirm me my audio and video both are clear or not. So in last class we have studied Fourier transform part 1. Today I will discuss again Fourier transform part 2. Okay, so we will continue Fourier transform in today's session. Just confirm me everything is perfect or not. Then I will start today's session. Okay. Anybody just confirm me everything is perfect. My audio is perfect or not. Okay. Anybody just confirm me my audio is perfect or not. Okay. Everything is perfect. Thank you. Okay. Now I am going to start today's session. In last session we have studied you can say basics of Fourier transform formula. Fourier transform formula. Okay. And next we have studied Fourier transform for some standard signal, and also Fourier transform properties, some 3-4 properties already we have studied. Okay. Now just wait 1 minute, I am going to start. Okay. So now in today's session I will continue from the same part. So first I want to recall something and I want to tell you exactly how can we get maximum marks in Fourier transform. Maximum means full out of full mark. So one thing you should remember, in last class we have studied 3-4 standard signal Fourier transform. So first thing you should know, approximate 5 standard signal Fourier transform you should know. Standard signal Fourier transform we should know, and we should be expert. We should be, you can say this is 5 na, and we should expert in Fourier transform property. So one thing you should remember, always you have to apply Fourier transform property. And which property is very very important. In today's class I will complete all the properties first. So just you should remember Fourier transform property is very very important, and all the question you should first try to solve by Fourier transform property. Clear the thing? So here some standard signal Fourier transform and all the Fourier transform property, you should be expert in this. Clear? So in last class we have seen, one more thing I want to tell you. Generally student will study in terms of either frequency domain or omega domain. Either frequency domain or in omega domain. I will tell you each and everything in both the domain. So you should make a table. One column for the frequency domain properties and one column for the omega domain property. So again I am going to take some more example, then I will go with the property of Fourier transform. Clear this thing? So now I am going to start. Okay. Now, so in last class some properties already we have seen. Again I am going to write linearity property already we have studied. Number 1. Second, time reversal. Second property, time reversal. You can say this is either time reversal or you can say this is a frequency reversal. Both are same. Time reversal or you can say frequency reversal. Third property, even and odd. If xt is real and even, if xt is real and odd, then which term will be present, which term will be absent. You are very much comfortable in this. Clear? And some standard signal already you know. What is the Fourier transform of ut? What is the Fourier transform of del t? What is the Fourier transform of pulse signal PT? What is the Fourier transform of pulse signal PT? What is the Fourier transform of constant? What is the Fourier transform constant? Just you should recall. Just you should recall. Do you remember this or not? Do you remember this or not? In both the domain, in frequency domain as well as in omega domain. In both the domain, do you remember or not? Just you have to concentrate. Okay. If you are not going to recall, again you have to read out your notebook. Clear the thing? So this basic signal at least. Now the next signal you can say that will be RT. Okay. I will solve RT by the multiplication of T property like this T times of UT. You can find out RAM signal by this property multiplication by T in time domain. Clear the thing? So later we will study. Now the next signal I am going to start. Next example. One thing you should know first. Normalized Gaussian pulse. Normalized Gaussian. Okay. So if I want to tell you the normalized Gaussian like this, suppose this is x of t and this is t, and mathematically I am going to write e raised to power minus pi t square, e raised to power minus pi t square, and at t is equal to 0, this value is 1. At t is equal to 0, this value is 1. What will be the area under this curve? So you should know this thing, e raised to power minus pi t square dt. From minus infinite to infinite, this area is nothing but 1. And one more thing you should know here, what is the Fourier transform of Gaussian signal? You should remember directly this, e raised to power minus pi t square Fourier transform, continuous time Fourier transform is same as it is, but in frequency domain. Just you should remember this thing, e raised to power minus pi t square Fourier transform is the same as it is, only you should replace t to f. So only this is the only signal which time domain function and spectrum looks like a same signal. Clear thing? So this Fourier transform, how looks like this Fourier transform? As it is same, only you should replace t to f. So this Fourier transform, what you will get? Only this will be f, and this will, you can say xf is nothing but e raised to power minus pi f square, and same function you will get. This is 0 and this is 1. So both the shape is same, only t will be replaced by f. So this thing you should remember. What you will remember? E raised to power minus pi t square Fourier transform e raised to power minus pi f square. You should remember this. Clear thing? You should remember this. Now I am going to take another properties. Okay, now, so next property just note down. Time is scaling. Next property is time is scaling. If x of t Fourier transform is xf, then what will be the Fourier transform of x of at? If xt is scaled by a, what will be the Fourier transform? You can write 1 upon mod a xf by a. So here, if you will multiply time with constant a, then frequency will be divided by constant a. Similarly, if you will write this like this, if you will write in this way x t by a, then what you will get? You can say here this constant is 1 by a. So what you will get here? This is nothing but mod a x. This is af. You will get like this. So you can also say this is a frequency shifting property, frequency scaling property or time scaling property. Both property you can say. Either you can say time scaling or you can say frequency scaling. Okay, so just note down this property. And what will be in omega domain? Omega domain you can also write this thing. This thing you can also write in omega domain. So x of at, what is the Fourier transform? This is 1 upon mod a x f, this is x omega by a. So either you can write in F domain or you can write in omega domain. Again, I am telling you, you should create a table, and in one column you should write all the property in frequency domain, and in another column you should write all the properties omega domain. Okay, all the properties in omega domain. Clear this thing? Now my next question, clear this? Now I am going to ask you next question, and you have to tell me the correct answer. You have to tell me the correct answer. Now, next example I am going to consider, x of t is given e raised to power minus t square by 2. What is this Fourier transform? What is this Fourier transform? xf is equal to question mark. What is this Fourier transform? What is this Fourier transform? How we can find out? This is, first you can see this is t square. T square means Gaussian, and one thing you should remember, you cannot solve this by integration method. You cannot solve this by integration method. Only property, or by only property you can solve this. So how we can solve? Already we know e raised to power minus pi t square Fourier transform e raised to power minus pi f square. Already we know this thing. Now if I will multiply here kt e raised to power minus pi, this is k, t will be multiplied with kt, this will be the kt square. Can I put here? So xt will be xkt. So what will be happened here? What will be happened here? 1 upon mod k. 1 upon mod k. Can I write e raised to power minus pi? What will be f? F by k whole square. F by k whole square. Can I use this property xat? In place of a, I have used here k. So if this is xt, if this is, you can say xt, xt is like this. So what will be the xkt? Just I am going to replace t by kt. So this kt square, here 1 upon mod k e raised to power minus pi, f will be modified f by k whole square. Now you can find out the value of k. You can comparison e raised to power minus pi. This will be the k square t square, and this value is nothing but e raised to power minus t square by 2. E raised to power minus t square by 2. So what will be the value of k? You can compare this to, So what we can say here, t square by 2 should be equal to pi k square t square. Can I write? So you can say this and this will be cancelled out. What k you will get? So here k square you will get 1 upon 2 pi. 1 upon 2 pi. So what will be the k here? K you will get 1 upon root over 2 pi. If I will do any calculation mistake, please correct me. Clear this thing? So now you have find out the value of k. We can put value of k here. So you will get the answer for this Fourier transform. So what will be the answer? What answer you will get? So e raised to power minus t square by 2 Fourier transform, what you will get? K is nothing but 1 upon 2 pi. So 2 pi you will get here. This is root over 2 pi. E raised to power minus pi. Here this is f square by k square. And k square is nothing but 1 upon 2 pi. So this will be 1 upon 2 pi. So what answer you will get? E raised to power minus t square by 2 Fourier transform. Root over 2 pi e raised to power, this pi and pi square, e raised to power minus 2 pi square f square. This will be the answer. Clear this thing? So if you will not get exact Gaussian, but you will get here t square term. So just you should remember, this will be solved by the standard property, by the standard Gaussian signal. So by standard Gaussian signal, you can apply here scaling property. Clear this thing? Anything now I can provide you. You can solve to any kind of Gaussian function. Now you can solve. Now if you want to write this in terms of omega, suppose you want to write this in terms of omega, what will be the answer? If examiner will ask you this thing in terms of omega, easily you can write in terms of omega. Just you can replace this 2 pi f by the omega. Clear this thing? So you can write in terms of omega also. Clear this thing? Everybody clear this? So any Gaussian signal can we solve? So right now this 5 standard signal, at least you should know. Clear? Next property. Now I am going to tell you many number of properties So in today's lecture, now I am going to tell you many number of properties, and then I will take questions from that property. Next property, just note down next property. Next property is time shifting. Next property is time shifting. Okay, next property is time shifting. This thing is clear to all of you. Okay, now next property is time shifting. And generally student remember this property. All the student remember this property. What is the time shifting property? So if xt Fourier transform is xf, or you can say x omega, then what will be the Fourier transform for xt minus t0 or t plus t0? What will be the xt minus t0? So just you should remember, if this will be time shift, in frequency domain exponential term will be multiplied. So here e raised to power, if this is minus, this will be minus, if this will be plus, this will be plus, j 2 pi f, multiply this shifting, this multiply shifting is t0 and multiply with xf. Clear this thing? Again I am going to tell you, if this is minus, this will be minus, this will be plus, this will be plus, just you have to multiply exponential term e raised to power j 2 pi f, multiply with shifted parameter. It can be td, it can be t0, it can be anything. Just you have to put this value. Now in terms of omega, what you can write, e raised to power minus plus j 2 pi f is omega t0 into x omega. Hear the thing? So in terms of omega and in terms of f, you should remember. Getting? One thing you should remember, if this is minus and if this is plus, so minus then minus, plus then plus. Minus then minus, plus then plus. Clear this thing? Now the next property. How we can use this property? So let's see. I am going to tell you one best example here. Let's see. So suppose I am considering one example. One signal is given. Suppose for example, one signal is given x1t, and this Fourier transform is suppose x1 of f, and one more signal x2t, and this x2t Fourier transform is x2 of f. So I am going to consider two signal, and now if I want here, you can see x1f, both are suppose this x1f I am going to assume this is nothing but xf e raised to power j 2 pi f t0. Suppose xf, multiply this, and x2f is nothing but xf e raised to power minus j 2 pi f t0. Suppose like this. So I am going to assume xf is like this and x2 is like this. Then what will be x1t and x2t? So can I say xt Fourier transform is xf? Then what you want? I want xf multiplication this. So what will be this x1t? So x1t you can write, what will be the x1t? So just this is the shifted version of this. How much shifted? So can I say, if you will shift xt minus, here this is plus, so this is plus, how much shifted? t0. xt plus t0. So what is this Fourier transform? This Fourier transform is this one. What is this? Continuous time Fourier transform. So what is the x1t? Continuous time Fourier transform. This is nothing but xt plus t0. This is nothing but xf e raised to power j 2 pi f t0. Can I write? Now the second signal x2t, and x2t is nothing but x of, I am going to assume t minus t0. Why I am going to assume t minus t0? Because this is minus. So what will be this Fourier transform? This is nothing but xf multiply e raised to power, this is minus, so this is minus j 2 pi f t0. Can I say like this? So now I have assumed two signal x1t and x2t. First signal is xt plus t0, second signal is xt minus t0, and Fourier transform already you have find out. Now what I want to tell you, if this is equation number 1 and if this is equation number 2. So if I will add both the equation, so equation 1 plus equation 2, what result you will get? So equation 1 plus equation 2, you will get like this. Can I apply linearity property? Yes, we can apply linearity property. If you will add this two signal, this Fourier transform will be also added. What will be this result? E raised to power j 2 pi f t0 plus e raised to power minus j 2 pi f t0. Can I take common this parameter xf? Can I write in this way? And what will be the left side? This both signal will be added and this both signal will be like this. So can I write x of t minus t0 plus x of t plus t0? Can I say? So xt minus t0 and xt plus t0 Fourier transform you will get like in this way. And what you can write this term? You will write this term e raised to power j theta plus e raised to power minus j theta is nothing but 2 cos theta, is nothing but 2 cos theta. Okay, what is the cos theta? E raised to power j theta plus e raised to power minus j theta divided by 2. Divided by 2. So what you will get here? This is nothing but 2 cos theta. Theta is 2 pi f times t0 multiply xf. Multiply xf. And what will be the left sided? X of t minus t0 plus x of t plus t0. Clear this thing? Now, this is very important property. Very few people generally use this property. Very few people, and in previous year gate, they have asked many time from this property. They have asked question many time from this property. Generally, student remember multiply cos here. What will happen in right side? No. Now I am going to take reverse property. If I will multiply cos here, what will be happen in time domain? If xt Fourier transform is xf, so how you remember this thing? How you remember this thing? Clear this thing? Now, so how you can remember this? This is the new property. If you have one term xt and xt Fourier transform is xf, if xt Fourier transform is xf, and now if you are going to multiply here cos theta, cos 2 pi f, you can say cos omega into t0 multiply with xf. Then what should be happen with left side? What should be happen with left side? What should be happen with left side? So left side signal will be, left sided signal will be shifted this amount one time left side and one time right side. So what here you will get? One time xt minus t0 and plus x of t plus t0. And here this 2 you can put here this 2. Here you can put this 2. So now you should remember, if you will multiply right sided Fourier transform with cosinusoidal, what will happen? Left sided signal will be one time left shifted and one time right shifted, and magnitude will be half. Magnitude will be half. Clear this thing? And magnitude will be half. This is very important property. This is very important property. Okay. Generally, we study opposite property. Opposite property also I will tell you. If we will multiply cos here, don't worry about that. But examiner are targeting question from this thing. So how you remember? If you know the Fourier transform, and suppose if cos will be multiplied here, then what will be happen? Left sided signal will be shifted. Left sided signal will be shifted. Suppose you know anything Fourier transform except, suppose I am going to assume this Fourier transform is suppose any rectangular signal, and if cos is multiplied here, and you know the left sided signal, just you have to shift left and right and you have to add. Clear? I will take question from this part, don't worry. Clear? So just you should remember this property. Next property, clear this? Now the next property. This is very important property. Next property. So how you remember this? If you will multiply cos to right side, means with Fourier transform, left sided signal will be shifted one time left and one time right. How much left? This amount, t0 left, t0 right. You can also write this in terms of omega. What you can write this in terms of omega? If this is x omega, you can see from here, if this is x omega, this will be only omega, nothing will change. So just you can write, this is nothing but cos and this is omega into t0. In place of t0 you can write anything, and what will happen here? The same thing. So you can also write in terms of omega. You can also write this thing in terms of omega. Clear? Now the next property. Next property is the frequency shifting. Next property is the frequency shifting. So right now what we have studied: linearity property, reversal property, even and odd property, time scaling property, and time shifting property. Now the next property is frequency shifting property. frequency shifting property. Clear? So in suppose I am going to assume if xt Fourier transform is xf, or you can say x omega, then what you want, I want to shift this frequency. So if this frequency is shifted f minus f0, you can also write anything f minus fd, anything you can write, then what will be the left sided? Left sided signal you will multiply with exponential term e raised to power j 2 pi. How much amount of shifting? This is f0 into t. You should concentrate here. In time shifting property. If you are going to shift t minus t0, what is the Fourier transform? xf e raised to power, this is minus then minus j2 pi f, this is t0. Here this term is 2 pi f, then this shifting, this time. So this function should be in terms of frequency domain, not time domain. So here time parameter should be constant. Here this is a function of time. So here frequency parameter should be constant. That's why this f is f0, and this f0 is shifted parameter. Now one important thing, if this is minus, this is plus, and if this is plus, this is minus. Just opposite. Here if this is minus, this is minus. If this is plus and if this is plus, here just opposite. If this is plus, this will be minus. If this is minus, this will be plus. One more thing you have to concentrate. This is a function of time. And this is a function of frequency. Or you can say x of like this. This is a function of frequency. Clear this thing? And this is a function of time. So here you cannot put frequency term. Frequency term should be constant. Clear this thing? So like this you should just remember. You cannot get wrong in Fourier transform property. Clear? In terms of omega you can also write. If you want to write this x of omega minus or plus omega 0, what will be the left sided? Left sided you can write this is xt. Multiply with, if this is minus then plus, plus then minus, this thing you can write e raised to power plus minus j. This 2 pi f0 you can write omega 0 into t. You can write in this way. If this is minus, this will be plus, or you can say if this is plus, this will be minus. If this is minus, this will be plus. Getting this thing? Just you should remember this property. Clear the thing? Now again I am going to ask you one thing. If this is xt, and if this Fourier transform is xf, this is xf, and xf is a complex quantity. If xf is a complex, when you will get xf complex? When xt is neither even nor odd. Then what you will get? xf is a complex. Getting? Now if xf is a complex, you can find out here magnitude spectrum, and you can find out here angle spectrum. Can I say? So here you can find out this is magnitude spectrum, and this is angle spectrum. Can I say? Now my question, if xt Fourier transform is xf, and this magnitude and phase spectrum already you know, then my question, here and here, ht minus t0, magnitude spectrum and phase spectrum will be same or different. And here also I want to ask you, magnitude and phase spectrum will be same or different. Here what will be the magnitude spectrum of this? If you want to find out this, magnitude spectrum will be same or different, and phase spectrum will be same or different. And again here this magnitude and phase spectrum will be same or different. This is my question. If you can tell me here in this case, what will be this magnitude spectrum? So you can write x omega minus omega 0 or x f minus f0. Suppose you are getting this thing. What will be this magnitude spectrum? If any signal will be shifted, this is bus frequency domain you are going to shift. So this magnitude spectrum will be magnitude of f, magnitude x f minus f0. This, what will be the magnitude part of this? Magnitude of f minus f0 and angle of x f minus f0. Like this. So just I want to ask you, here magnitude and phase spectrum will be same as it is, or this will be different? This is my first question. Second question, from here I am going to write here again, if xt Fourier transform is xf, and this magnitude spectrum is xf, and phase spectrum is angle of xf. Clear? Now again I am going to write xt minus t0 Fourier transform is xf e raised to power minus j 2 pi f t0. Now what will be this magnitude spectrum? Suppose this is yf. Suppose I am going to say this is y of f. So what will be the magnitude of yf and what will be the angle of yf? In terms of xf, this question has been asked in previous year GATE exam. So what can I say? If you will going to find out this magnitude and this magnitude is same. This magnitude is 1 and this magnitude is mod of xf. So what we can say here, mod of yf is equal to mod of xf. So magnitude spectrum will be same. Here magnitude spectrum will be same. What will be the angle spectrum? This angle and this angle. So here another angle will be added. Angle will be added. So what we can say, this is nothing but angle of xf, and what will be this angle? E raised to power j theta. And what is theta? Minus 2 pi ft0. So here some extra angle, or another angle will be added. And what is the angle? You can find out from here. If two signal is multiplied, what will be the angle? Angle will be added. Control system already you have studied. So this angle and this angle. So here angle will be changed. So this thing just you should remember. After time shifting property, magnitude spectrum is same but phase spectrum is different. Here if I want to ask you, this xf and this mod of xf minus f0, both signal is different. So magnitude spectrum will be different. So this is different. And what will be the angle spectrum? If signal will be shifted, definitely here this angle will be different. Spectrum will be different. So examiner can ask you this question, after time shifting property, which spectrum will change and which spectrum will same? So magnitude spectrum will be same but phase spectrum will be different when you are going to shift signal in time domain. Now the second question, when you are going to shift signal in frequency domain, then magnitude spectrum as well as phase spectrum both will be changed. Clear? So just you should remember this thing also. Clear? Now I am going to use this property. Okay, now so if you will add two signals, which signal if I will add? So just note down the use of this property. If I am going to write here e raised to power j 2 pi f0 into t xt plus one another signal e raised to power minus j 2 pi f0 t into xt. What is this Fourier transform? This Fourier transform is nothing but x of f, and this is plus, so this will be minus f minus f0, and this Fourier transform is plus what you will get here, x of f plus f0. And what you can write this term you can write e raised to power j theta plus e raised to power minus j theta is nothing but divided by 2 is cos theta. So if you want to write here cos 2 pi f0 into t, can I write? Multiply xt. What is this Fourier transform? You have to divide here, here this is for j theta plus or minus j, divide by 2 is the cos theta. So you have to do here divide by 2. So right sided here it will be divided by 2. So what can I write here? X of f minus f0 divided by 2 plus x of f plus f0 divided by 2. Can I say? Again, this is very important property. If you will multiply cos in time domain, earlier what we have studied, multiply cos in frequency domain. Now I am going to consider multiply cos in time domain. Then what you will get the answer? So here answer, your Fourier transform will be shifted. One time f0 minus side, one time f0 plus side, and amplitude will be divided by 2. amplitude will be divided by 2. Clear this thing? Amplitude will be divided by 2. This property is called modulation property. This is called modulation property. This is called modulation property. Or by one example I want to explain you. Suppose this is empty, one signal is given and this continuous time Fourier transform. Just I am going to assume this signal. Just I am going to assume this signal like this. And this is nothing but AMF. This is nothing but AMF and this is in frequency domain F. Suppose this frequency is W and this frequency is minus W. Now if you will multiply this empty multiply by cos theta. Cos theta means I am going to write cos 2 pi FCT. Suppose if I want to multiply any signal with cos signal, then what will be happen this Fourier transform? This Fourier transform will be M F minus how much shifted FC, F minus FC plus M of F plus FC. And amplitude will be 1 by 2. Amplitude will be divided by 2. This answer you will get. Suppose this amplitude I am going to assume K. I am going to assume K. Then what will be this spectrum? Then spectrum, what will be this spectrum? This is nothing but M of F. Okay, you can say for this Fourier transform, I am going to write this M dash of F. Clear? M dash of F. What you will get here? This spectrum will be shifted here and this spectrum will be shifted here. Getting? And what will be the amplitude? This amplitude will be K by 2. This will be K by 2 because amplitude will be half. And this frequency will be FC and this frequency will be minus of FC. This width is 2W and this width is 2W. Like this. Just you should remember, if you will multiply cos in left sided, what will be happen with right sided? Right sided signal will be one time shifted, right side one time shifted left sided, and magnitude will be half. Magnitude will be half. Same for the reverse case. Same for the reverse case. Earlier we have studied, if we will multiply cos here, then left sided signal will be one time left shifted, one time right shifted, and magnitude will be half. Just by theoretically you should remember this. If you will multiply cos here, so this signal will be shifted one time left, one time right, amplitude will be half. Clear this thing? So both sided multiplication of cos should be very clear to you. Getting this property? Clear this property? Now the next signal. If only you want to find out cos omega 0 t, what is the Fourier transform of cos omega 0 t? What is the Fourier transform of cos omega 0 t or cos 2 pi f 0 t? What is this Fourier transform? So can I say here xt is 1? So if xt is 1, so if xt is equal to 1, so what is the xf? Xf is nothing but one Fourier transform is del f. What is the x omega? 2 pi del omega. So what will be the Fourier transform of cos omega 0 t? What will be the Fourier transform of only cos omega 0 t? So can I write here, what is the Fourier transform of 1? 1 is nothing but del f. So if you will multiply here j 2 pi f 0 t into 1. What is this Fourier transform? Del will be shifted f. Here this is plus, so this will be minus del f minus f0. Can I write? Again e raised to power minus j 2 pi f0 t into 1. Then what will be happen here? Del f plus f0. What will be happen here? Del f plus f0. Can I write? Now if you will add this 2 and divide by 2, what you will get? Cos 2 pi f0 t. What is this Fourier transform? Both will be added. So what answer you will get? Del of f minus f0 plus del of f plus f0 divided by 2. What will be this spectrum? Spectrum you will get like this. Here you will get one impulse at f0 and here you will get one impulse at minus f0. And what will be the amplitude? 1 by 2. This is 1 by 2 and this is 1 by 2. This is frequency f. This will be the answer. One thing you have to concentrate here. Here ut is not multiplied. Please remember, if you remember cos omega 0 t ut Laplace transform. In Laplace transform, always you find out cos omega 0 t dot ut. But in Fourier transform, here only this is cos 2 pi f 0 or cos omega 0 t. No cos omega 0 t multiply ut. If you will multiply ut here, everything will be different. Everything will be different. Clear my point? So this thing you have to concentrate. Here ut is not multiplied. But in when you will find out Laplace transform of cos omega 0 t, ut will be multiplied. Ut will be multiplied. Clear this thing? Clear the thing? What will be cos omega 0 t Fourier transform in terms of omega domain? What will be this answer in terms of omega domain? So if I want to ask you cos omega 0 t, what is this Fourier transform? What is the one Fourier transform? Is nothing but 2 pi del omega. 2 pi del omega. What you can write here? 2 pi del omega minus omega 0. And what will be this? 2 pi omega plus omega 0. So what will be this quantity? 2 pi and 2 will be cancelled out. Pi del of omega minus omega 0 plus pi del of omega plus omega 0. This will be the answer. So you have to concentrate, especially cos omega 0 t in terms of frequency domain or in terms of omega domain. So omega domain spectrum, what you will get? This is omega, and what will be this? You will get here at omega 0, and here you will get at minus omega 0. But what will be the amplitude? Amplitude will be here pi, and amplitude will be here pi. Just you have to concentrate. In F domain, this is 1 by 2, 1 by 2. But in omega domain, this is pi and this is pi. Clear? Again, one more important thing. Here ut is not multiplied. Not multiplied. Clear this thing? Now, what will be the Fourier transform for sine 2 pi f 0 t? So can I write directly? Can I write? Yes. Sine this minus this. E raised to power j theta minus e raised to power minus j theta divided by 2j. So here you will get terms 2j and this will be minus only. So what will be the answer? Sine 2 pi f 0 t Fourier transform del of f, which term will be negative and which term will be positive? This is very important thing. This Fourier transform is negative and this is positive term. This Fourier transform is here positive and this term is the second and this will be the negative term. So you have to concentrate here. Del f minus f0 minus of del f plus f0 divided by 2j. Divided by 2j. This is the Fourier transform of sine omega 0 t. Now come on the property. This cos omega 0 t is even function or odd function. This is even function. This sine 2 pi f 0 t is the odd function. What is the Fourier transform of even function? Only real part. So you are getting only real part, and sine omega 0 t is the only odd function. Fourier transform will be only imaginary part. So this answer will be only imaginary part. And this answer is only real part. So if you want to find out magnetic spectrum of this, okay, so you have to find out real part and imaginary part. Real part is 0. Then you can find out the magnetic spectrum. Okay, so let's see. One more thing I want to tell you here. What will be for sine omega 0 t? Sine omega 0 t Fourier transform. What you will get? Can I write? This is pi del of omega minus omega 0 minus pi del of omega plus omega 0. Can I write? So here what you will get? This term is the negative divided by j. If you can put j upside, so this j will become, this will be plus and this will be minus. You have to concentrate on this. So in exam, always from the basic you should find out. Don't remember this. Theoretically you should remember, if I will multiply any signal with cos, you will get a signal shifted version. If 1 is multiplied with cos, then Fourier transform 1 is the impulse. So cos Fourier transform is 1 impulse right side, 1 impulse left sided. Always I suggest you should use frequency domain. Don't use omega domain. In last portion only you should convert frequency domain to omega domain. 99% chances you will not get any calculation mistakes. But if you will use generally omega many time, you will get the calculation mistakes in terms of pi and 2 pi. Clear this thing? You will get mistakes in terms of pi and 2 pi. Clear this thing? Just confirm me everything is clear till now or not? Clear this? Cross multiplication both sided should be very clear, and frequency shifting and time shifting property should be very clear. Getting? Okay. Now one thing also you should remember, here ut is not present. Here ut is not multiplied. Okay. Now the next property. Now the next property. Clear this thing? Now the next property. Next property of the Fourier transform. Next property of the Fourier transform, differentiation. Next property of the Fourier transform, differentiation. Differentiation in time domain. Differentiation in a time domain. In a time domain. Differentiation in time domain. It means if xt Fourier transform is xf or x omega, then what will be the Fourier transform of d by dt xt? So what is the Fourier transform of d by dt xt? Many people already know this thing. What we have to do here, j2 pi f term we will multiply. So we will multiply here j2 pi f. Also for omega you will multiply j omega into x omega. Can I write? 2 pi f is nothing but omega. You can also multiply with j omega x omega. Getting? Now what is the second differentiation? If again d2 dt square xt second differentiation, then what you will get? Again you will multiply the same quantity j2 pi f. So what you will get? j2 pi f, can I do whole square into xf, or you can also say this is nothing but j omega whole square into x omega. So for the nth differentiation, this is dn by dt raised to power n xt. What is this Fourier transform? j2 pi f raised to power n. So here you can say if in even number of differentiation or odd number of differentiation, then j raised to power you will get. According to, you can say answer will be positive or negative. But just you should remember in this way, this is xf, and in terms of omega, j omega raised to power n x of omega. Clear this thing? Ready? So just you should remember, if suppose you know what is the ut differentiation, what is the Fourier transform of ut, what is the Fourier transform of ut, already we know. How you remember? You should remember Laplace transform, 1 upon s, s means j omega and omega means 2 pi f, 1 upon j 2 pi f plus del f by 2. This is the Fourier transform of ut. Like this you should remember. Now what is the differentiation? D upon dt ut is nothing but del t. So what is this Fourier transform? Just you have to multiply. You have to multiply j2 pi f. So what you will get here? j2 pi f multiply here j2 pi f. Again this is the second term, j2 pi f multiply del f by 2. So this will be 1. What answer you will get? 1. And this differentiation is del t. So del t Fourier transform 1 plus this quantity, and already you know the property of del function, xt multiply del t is nothing but x0 del t. Already you know this thing. So or you can say xf. Can I put in place of tx? Del f. So what you will get? This is x0 del f. Can I write? So just you should remember this property of del function. So what answer you will get? Here f will be 0. 0 multiply anything will be 0. So second term will be 0. Your answer is 1. Okay, your answer is 1. This property is perfect. Getting? Now the next. So differentiation property, many where you can use. You can use. This property is also a very important. Very important property. Clear this thing? So just you have to multiply j2 pi f. Clear this thing? Now the next property. Now the next property is the integration. Integration. I will take good quality of example from the previous year after completion of this property. So just note down next property. Integration in time domain. Integration in time domain. Okay. Now if xt Fourier transform is either xf or x omega, then what is the Integration means minus infinite to t xt dt. And actually this value you can also write. This is nothing but minus infinite to 0 xt dt plus 0 to t xt dt. Can I write in this way? Can I write in this way? And if you are saying this quantity is k, suppose this quantity you can also say k. Getting this thing? Can I write? Now I am going to write what will be this Fourier transform xt dt. What is this Fourier transform? What is this Fourier transform? Here in differentiation you have multiplied j2 pi f. Here you have to divide j2 pi f. You have to just divide j2 pi f. But one initial value is also present. Here initial value is also present. What initial value we have to put? Del f by 2 multiply x0. Multiply x0, capital X0, that is not small x0, that is capital X0. That is capital X0. Clear the thing? Now in terms of omega, this part is very important. This part is very important. You should remember this. So integration property, except by j2 pi f, you will get one another term. One another term is del f by 2 into x0. This is capital X, not small x. Clear? So this capital X value at 0. Clear? This term you are getting because of the initial value. In terms of omega, what you can write? This is x omega divided by this. This is x omega divided by j2 pi f is nothing but j omega plus what you can write? This 2 pi del omega, 2 to cancel out, pi del omega multiply x0. You can also write in this way. Clear? Now again we have to check. This. If del t Fourier transform, already you know del t Fourier transform. So del t Fourier transform is 1. So what will be the integration of del t dt? This is from minus infinite to t. And you can say this is nothing but either x omega or you can say x f. And both the value x0. What you will get? X0 is 1. Clear? So now what will be this Fourier transform? You can write xf or x omega. Both value is nothing but 1. So what you can write? 1 upon j2 pi f plus del f by 2 multiply x0, and x0 is nothing but 1. You always constant. What is the x omega or xf? Constant 1. So what will the value at 0? 1. So this will be multiplied with 1. Same answer you are getting. And this thing is nothing but ut. Already we know the Fourier transform of ut is 1 upon j2 pi f plus del f by 2. Clear the thing? Now this del t is even or odd? Even function. You are getting here result real part. But ut is not a even function, neither even nor odd. You are getting both the part. Every property will be always satisfied. How many property you can apply in one question? If you are very expert in property, you can solve anything in very quick way. But practically this is tough to apply many number of properties in one question. This will be only you should be expert after some practice. Clear the thing? All the properties should be remembered in your mind first thing. This is very important. That's why I am going to tell you each and every property. Otherwise, I will draw a table and I will write all the properties. Now I hope you are remembering all the properties. Clear? And in terms of both omega and f, we are studying. This is very important thing. Very few people in India will study in both the terms, in terms of f and in terms of omega. Generally they will use one term, either f or omega. Clear this thing? Now, so if suppose for example you want to find out integration of ut dt. Suppose you want to find out an integration of ut is ramp function, and this is from minus infinite to t, and you will say this is ramp function. Suppose always by using one property, this is not always calculation will be easier. You should always try. Just we can try to find out integration of ut by using this property. What answer you will get? Ut Fourier transform is already this term, and this term is divided by j2 pi f. So this term is divided by 1 upon j 2 pi f whole square. You will get this term. And this term again del f divided by 2 into j 2 pi f. This is the first part. What will be the second part? Plus del f by 2, del f by 2. Multiply this x0. This was your xf. And what will be the x0? 1 upon 0 is infinite, plus del 0 is also infinite. Infinite plus infinite is infinite. You will get here infinite. What answer you are getting? Infinite. This answer you are getting infinite. So sometime some property cannot be applicable. So how we can find out the Fourier transform property? Don't worry, nobody will ask you Fourier transform for RT. Don't worry, nobody will ask you. So just you are getting here answer is infinite. Second, you have one another choice. If you know the Fourier transform of ut, then we can use multiply t property. We have to check by this also. We have to check by this property also. Getting clear this property? Differentiation as well as integration. So just you should remove this part. Okay, this thing you can also write in terms of omega. You can also write from here omega. You can also write x omega by j omega, and this again you will get same answer. Clear this thing? Now the next property. Clear this? Now the next property. Please confirm me, everybody. Till now everything is clear or not? Please everybody respond me. Always you have to respond. Okay. Now the next property, integration and differentiation already we have studied. Now the next property is multiplication by t. Same, multiplication by t. In time domain. Then what will happen? So if xt Fourier transform is either xf or you can say x omega, then if you will multiply t here, t times of xt, then what will be the Fourier transform of these? Then we will get here j upon 2 pi. Differentiation of, or you can say minus 1 upon, you can also write minus 1 upon j 2 pi, or you can say write like this, j upon 2 pi d upon df except. You can write in this way, j upon 2 pi d upon df except. Here in frequency domain you are getting the pi term. Only this is the only property. Where in f domain you are getting pi term. So this property is easier for the omega domain. What you will get in omega domain? Omega domain we will get only j multiply d by d omega x omega. So here this property is easier in omega domain. So I suggest you should remember this. It's your wish. Either you should remember this or this. But only this property in omega domain is easier. All the property is easier in frequency domain. So just here to concentrate. Suppose for example, if this is t raised to power n xt. What is this Fourier transform? So what can I write? J here, this is j raised to power n divided by 2 pi. This is j raised to power n divided by 2 pi. This is nothing but d dn upon df differentiation n times into xf. Like this. And in omega domain, so this property I suggest you don't remember this thing. You should remember in terms of omega. So in omega domain, what you can write? This is j raised to power n. This is n time differentiation. And this is x omega. You should remember like this. So just if you will multiply t here, right sided, what will happen? Right sided differentiation you will get. If t raised to power 1 time differentiation, t raised to power n, n time differentiation, and again multiply with j raised to power n. So this omega domain I suggest you should remember. Like this. This property you should remember. Clear the thing? This property you should remember. Now our question. Just you want to find out TUT. Suppose you want to find out UT Fourier transform. Already you know 1 upon j 2 pi f And in omega domain, we can write 1 upon j omega plus this is pi del omega, pi del omega. Can I write? If you will multiply t here, so t times of ut. What will be the answer? By this property, you can find out this is t times of ut, j multiply differentiation. J multiply differentiation. So you will multiply here j, you will multiply here j, and differentiation of this quantity, differentiation of d upon d omega, 1 upon j omega plus pi del omega. So what will be the differentiation of del? Again, that is a doublet function, and we don't have to use doublet function. So this will be the doublet. So practically you are not going to find out. You are not going to find out TUT Fourier transform. That's why nobody will ask you till now what is the Fourier transform of TUT or RT. Okay. So just you should remember RT Fourier transform we don't have to find. We don't have to find. Clear? We don't have to find. Clear thing? Wait for the energy. I am coming on the energy. Just wait for the energy. Okay. Some 3-4 properties left and energy, partial energy theorem today I am going to tell you. Okay. And you are asking, sir, energy of a sampling function or you can sing function 3t by 4. Easily we can find out. Clear this thing? So clear this property. So just you should remember multiply by t, and in very rare case we will use this property. This property generally will not use. So if you forgot this property, don't worry about this. Generally will not use this property. But just remember this thing you should remember. This thing you should remember. You can put j here also. Generally, how student will remember this? Here one important thing, this is not 2 pi raised to power n. 2 pi raised to power n, this is not. Some student will put j here. This is minus j. So minus j txt will be here differentiation of this. So if you will differentiation here, what will be the left sided? Minus j multiply t. Minus j multiply by t. And if you will do here n time differentiation, then what you will get here? This is nothing but j raised to power n, and if here you will put j upside minus j, so what you will write here? This is minus jt raised to power n. This is the actual property. If you will differentiate here n time in omega domain, just here to do left sided minus of jt raised to power n. If this is raised to power 1, this will be raised to power 1. Clear this thing? So it's on you how you remember this property. Okay, and very rare case we will use this property. Clear? Now the next property. Okay, you can ask this question to anyone. What is the Fourier transform of RT? Just you should try, and what answer you are getting, just you should try this thing. Okay, you can ask to anyone, what is the Fourier transform of RT? You just ask this thing. Okay, now the next property. Okay, now the next property is a very important property, convolution in a time domain. This is very important property, convolution in time domain, and this is my favorite property, convolution in time domain and convolution in frequency domain. So if two signals we have given, suppose x1t, convolution x2t, and suppose we are saying this is xt. So xt is nothing but convolution of two signal x1t convolution x2t. What will be this continuous time Fourier transform? What is this Fourier transform? Is the multiplication in frequency domain. So this will be nothing but x1f dot x2f. This is multiply. So x1f and x2f will be multiplied. Okay, what will be in omega domain? Directly you can write x1 omega dot x2 omega. So in omega domain or f domain you can write. So just you should replace f2 omega. Clear the thing? Now the next property, similar property, convolution in frequency domain. Convolution in frequency domain. Here you can say this new signal is xf, or you can say this new signal is x omega. You can write, because you have written here, this signal is xt. Now, what will be convolution in frequency domain? So, if convolution in frequency domain, and this property you can also say multiplication in time domain. Multiplication in a time domain. So, in time domain, you are going to multiply two signal. And this property you can say convolution in time domain, then multiplication in frequency domain. Multiplication in frequency domain. Multiplication in frequency domain. Multiplication in frequency domain. Clear the thing? Multiplication in frequency domain. Now, what will be this property? What will be this property? Here many students are wrong in this property. In this property, this is very, very important. This is very, very important, and many students are wrong in this property. Many students are wrong in this property. Where they are wrong, this I want to tell you. This is x1t multiplication x2t, and this is nothing but new signal xt. What will be this Fourier transform? Continuous time Fourier transform is nothing but convolution of both the signal in frequency domain. x1f convolution x2f. This is convolution, and this signal you can also say x. So, if this side convolution, then in time domain multiplication, or you can say if here multiplication, this side convolution, this side convolution. Clear? What will be in omega domain? This is very, very important thing. This is in frequency domain. But what will be in omega domain? So, in omega domain, if you will write here x1t dot x2t, then, and this is xt, what will be in omega domain? Omega domain you cannot convert directly. This is x1 omega convolution of x2 omega, and here 1 upon 2 pi term you will get. 1 upon 2 pi term you will get, and this is nothing but x omega. This is nothing but x omega. So we have to concentrate in a frequency domain, means f domain. You should remember very easily. How? If this side convolution, this side multiplication. If this side multiplication, this side convolution, no pi 2 pi term will be present. But in omega domain, this side convolution, this side multiplication. If this side multiplication, this side convolution with 1 upon 2 pi term, with 1 upon 2 pi term. So this term and this term, you should remember. You should remember. You don't get wrong here in this part. You don't get wrong here in this part. Clear the thing? You don't get wrong here in this part. Clear the thing? So this term is very, very important. This term is very, very important. Many times students get wrong here. Many times students get wrong here. Okay? Getting this property? Getting this property? Now, one question I want to ask you by this property. One question I want to ask you by this property. Clear? Now, earlier we have studied Fourier transform unit impulse constant. Today we will discuss Fourier transform of Gaussian signal. In last class we have studied Fourier transform of pulse signal, and Fourier transform of unit step, Fourier transform of ramp, Fourier transform of pulse. Okay. Now I want to ask you Fourier transform of triangular signal. Fourier transform. Clear this property? Fourier transform of triangular signal. Fourier transform of triangular signal. Now, Fourier transform of triangular signal, and how you can find out? How you can find out? How you can find out Fourier transform? So, next example I am going to consider Fourier transform of triangular signal like this, and this is xt, and suppose this is tau, this is minus tau, this is 0, and this is a, and this is t. What is the Fourier transform? What is the Fourier transform of this signal? Continuous time Fourier transform. So, by using formula, this is very tough to calculate. It will take time. So, just you have to create this signal. How we can create this signal? So, can I assume like this? If this is tau by 2, this is minus tau by 2, this is 0. And if this signal is x1t and this is t. Can I assume this amplitude is A? Can I assume this amplitude is A? And what will be the second signal? Second signal x2t, and suppose this signal is again, this is tau by 2, this is minus tau by 2, this is 0, this is 1. You should be expert in convolution, and already I tell you this convolution in very, very expert way. So this is minus tau by 2, from where convolution will start? Tau minus tau, and this is tau by 2 plus tau by tau, when convolution will end at tau, and both the bits is same, then you will get a triangle signal. So this convolution answer, what you are getting here? So x1t convolution x2t. Just wait. We have to concentrate on this magnitude. We have to concentrate on this magnitude. This answer is clear. You will get triangle signal. This will be tau. This will be minus tau. This will be 0. What will be the slope? Earlier I tell you slope is a into 1. This slope will be a. But what is the slope here? This is a and this is tau. This slope is a by tau. This slope is a by tau. This slope is a by tau. So this amplitude you cannot put a. You can put here a by tau. You can also choose this is a and this is 1 by tau. So generally what I will use, one amplitude generally I will use 1. Remaining portion I can put over the second. I will put over the second. So this is very important thing. Now what will be the slope? A by tau into 1. Slope will be, in earlier classes already I tell you, this a and this b, slope you will get a dot b. Clear this thing? Now this amplitude will be, the slope will be a by tau, then this width is tau, this amplitude is a. This amplitude is a. Clear this thing? So this the signal you can create by two-step signal, and this Fourier transform and this Fourier transform already you know. We know this Fourier transform. So this Fourier transform and this Fourier transform will be multiplied either in omega domain or in F domain. Anything you can write. So what will be this Fourier transform? This Fourier transform is nothing but this area. What is this area? Area is a by tau multiply. What is this tau? A by tau into tau. Can I write? What is this area? A by tau into tau sinc f tau. What is the width? That is tau. Sinc f tau. Can I write? What will be this Fourier transform? This Fourier transform is nothing but, and both the Fourier transform will be multiply. If in time domain signal will be convolution, in frequency domain signal will be multiplication, and this Fourier transform is nothing but, this is 1 and this is tau. What will be this area? 1 into tau sinc f tau. What will be the result here? This is sinc f tau, sinc square f tau. This tau cancel out. This is a sinc square f tau. This is the answer. So just you should remember, for the triangular signal, what result you will get? Sinc square. So what is this Fourier transform? Now directly you should also remember. This is tau, this is minus tau, this is 0, this is a. What is this Fourier transform? First you should remember, triangular signal Fourier transform is sinc square. So this is nothing but sinc square. What is the one-sided width? That is tau. So this is sinc square f tau. And that will be the multiply this value, only a. This is a. A sinc square f tau. This thing is clear, na? Okay, just wait. This is wrong. This tau and this tau will be cancelled out. This is a tau. And this will be a tau. This will be the a tau. Clear thing? And a tau is nothing but area. This is nothing but area. Clear? A tau sinc square f tau. Clear the thing? A tau sinc square f tau. Clear everybody? So how to find out triangular signal? How to find out in very efficient way? Just you should concentrate. This triangular signal we can create by two-step signal, and two-step signal convolution you will get triangle signal, and this step Fourier transform is sinc. This Fourier transform is sinc. Clear this thing? Now one more answer can be also possible. Here many answer can be possible. Now what can be the another answer? Clear this thing? Now this signal you can also create in different way. What is the different way? You can see here. Okay, now here total width is minus tau to plus tau. Suppose some another student are considering first signal in this way. Minus tau to 0 and this is 1. This is x1t. Now second signal he is considering in this way. This is 0 to tau and this is x2t. And what will be the height? Height will be a by tau. Now if I will ask you, what is the convolution of this two? Minus tau plus 0, from minus tau it will start, 0 plus tau, it will end at tau, both the width is same, you will get triangular signal. What will be the slope? A by tau into 1, a by tau. So this conversion, this again you will get this same answer, same answer. And what will be this Fourier transform, and what will be this Fourier transform? So what will be this Fourier transform? What you can say, this can I say shifted version? If you can assume this signal, this is a shifted version. So shifted, time shifting property we can apply. Time shifting property you can apply. So can I say, if this is a one signal from tau by 2 to minus tau by 2, this signal, if you will shift this signal right side and one time left side, so you will get this signal as well as this signal. Can I say? So what will be the Fourier transform of these? What will be the Fourier transform? This Fourier transform, or you can say this whole area is 1 into tau. This is tau, sinc f tau. Can I say? Multiply shifting property. Which side? Plus shifted. Plus shifted means e raised to power j2 pi f. J2 pi f multiply how much shifted? Tau by 2 multiply tau by 2. Can I write? What will be this Fourier transform? This Fourier transform nothing but what will be this area? This area is a by tau into tau. So tau will be cancelled out a. So this is a sinc f tau with this tau multiply e raised to power, this is right shifted, means minus j 2 pi f tau by 2. Can I say? Can I say? Now if you will do this 2 multiplication, if this multiplication, this and this will be cancelled out, this and this will be cancelled out, and you will get again same answer. You will get again same answer. So by different way you can create. In last you will get the same answer. In last you will get the same answer. Some student will also do like this. This both are exactly same shifted. Suppose this is pi by 8 shifted and this is 3 pi by 8 shifted. Then again answer can be different. Representation can be different only. Clear? So always you should try to use the previous one. Clear this thing? Now my next question, trapezoidal signal. Clear this signal? Okay, now, so what you have to exactly choose, always try to choose both the width and both the signal is in same way. One amplitude you can consider one, remaining how much you want, you can put over the second. Here I have used, here this was 1 and here this was a by tau. Clear this thing? Clear this thing? Now how you can find out Fourier transform of trapezoidal signal, or my second question, first suppose trapezoidal I am going to consider in this way. In this signal is given like this. Suppose this is xt and this is t. Suppose this quantity is minus 2 and this is 1, this is 0, this is 1 and this is 2, this is minus 1. Suppose this quantity is 10. This quantity is 10. First, how to create this signal? Total width is 4. Then what you can consider? One width you can consider 3, another width you can consider 1. No, you have to check how much time this sliding, or how much time this is constant. This constant time is 2 seconds. It means one width should be difference between two is the or you can say this slope is 1 second, means one signal should be with 1 and the difference should be 2. So difference should be 2 and one signal width is 1. So how many times this slope? It means one signal width already you have find out. So one signal width is 1 second. Can I consider in this way? This is 1 by 2, this is minus 1 by 2 and this is 1. Can I say? This is t. Now the another signal, remaining this width is 1, total width is required 4. So second width can I consider 3. So this is 3 by 2 and this is minus 3 by 2, this is 0 and this is t, and this signal is x2t and this signal is x1t. So what will be this two convolution? Convolution will start from minus 3 by 2, minus 1 by 2, minus 3 by 2, 1.5 and this is minus 0.5, minus 2 and this will end at 2. This thing is correct. When you will overlap here, so 1 second, this you will get the slope, remaining 2 seconds you will get constant, again at 1 second you will get the down slope. This answer is correct. Now what will be this amplitude? Just have to find out the slope. This height is 10 and this width is 1, slope is this is plus 10. and this slope is minus 10. So slope is plus 10. If you are considering this one, you can consider here 10. Here you can consider 10. Clear? So 10 into 1, you will get with 10 slope. You will get with 10 positive slope and again with minus 10 slope. So this amplitude will be 10. This amplitude will be 10. Clear this thing? So you have to, don't put this 10 and this 10 is same. No. If I will change this width to 2 seconds, this will be changed. So you have to concentrate on this. You have to concentrate on this. Clear this thing? You have to concentrate on this. Then what will be the result? What will be the result here? What will be the result here? The result will be this Fourier transform. What will be this Fourier transform? This area 1 into 1, this is 1, sinc f into 1. Can I write? Now, what will be this Fourier transform? This 10 into this width is 3. This width is 3. 10 into 3, that is 30, sinc f into tau. And what is the tau here? Tau is the 3. This is 3f. This is, you can say 3f. This is 3f. Can I write? Now, what will be this 2 multiplication? What answer you are getting? 30 into 1, 30, sinc f, multiplication, sinc 3f. Sinc 3f. You will get this answer. So, here you are not getting sinc square because 2 sinc width is different. And here pulse width is different. Pulse width is different. So, here 2 sinc you are getting. Now you can convert sinc into sine and sine. Now you can convert sinc into sine and sine. So according to the options, here trigonometric you can apply. Getting this thing? Can we solve this? Now my next question. If this is a previous year gate question, if 2 sinc are multiplied in time domain, then how you can solve? If 2 sinc are given in time domain, then how we can solve? Here duality property is very important. So most important property in whole syllabus. If you will ask me, sir, what is the most important property? Which one is the most important? That is the duality property. So clear this convolution and multiplication. Okay. Now one question if I want to ask you, suppose 2 signal are multiplied. Suppose 2 signal are multiplied. Then right sided that will be convolution. So what you have to try always you should try to find out multiplication part, or convolution always you should try to find out for the pulse signal. Okay, I will take some more example. Just wait. So remaining property first we have to finish. Remaining property. Then I will take some question from mix up of all the property. Clear? Now the next property. Clear this thing? Now the next property. If xt Fourier transform is xf or x omega. This property name is conjugation, or you can say conjugate. This property is complex conjugate. So if x conjugate t, what is the Fourier transform? This x conjugate of minus f or x conjugate of minus omega. So if you want to find out x conjugate Fourier transform, here Fourier transform will be revert, and also this will be conjugate. Clear this thing? Now the next property. Area property. And this is very important property. Area property. Now the next property is area property. Now, and this is very important property. What area property say? If xt Fourier transform is xf or x omega. Getting? What is the Fourier transform formula? Xf is equal to integration of xt e raised to power minus j 2 pi ft dt, and from minus infinite to infinite. Clear? And what is the inverse Fourier transform formula? What is the xt is equal to minus infinite to infinite e raised to power, x of f e raised to power j 2 pi ft df. Can I say? What will be this x0, capital X0? What will be the capital X0? You can say this is xf or x omega, anything you can say. What will be the x omega, or and this formula in terms of x omega, this is nothing but 1 upon 2 pi minus infinite to infinite. This is x omega e raised to power j omega j omega t into d omega. Can I write in this way? Yes. What will be the capital X0? Here this is xt e raised to power 0 is 1. It means X0 is the integration of xt dt. This is very important property. This is very important property. So if time domain signal area you can find out, it means x0 means Fourier transform at 0 position. So 0 position Fourier transform is always area of the time domain signal, is always area of the time domain signal. That's why always you are getting this Fourier transform is nothing but area into sinc, and you know sinc 0 is 1. Sinc 0 is 1 and you are getting this area. So if you can find out area of the time domain signal, it means Fourier transform you can easily get at the 0 position, either x omega or x0. Either x omega or xf, both are same. So this area if you can find out. So if left sided signal area you can find out, then right sided signal at 0 value easily you can find out. Here's the thing. So many time in all the 4 options, if they are going to provide you, you can check by this. If you are expert in property, area property and even and odd property, so most of the question directly you can take the answer. Sometime definitely directly you can take the answer. And if you are expert in all the property, then most of the question directly you can take the answer. So you should be expert in this. Clear this thing? Now from here, what you can get, x0, small x0 is equal to, then you can put t is equal to 0. If you can put t is equal to 0, integration of xf df. And this is from minus infinite to infinite, or in terms of omega, 1 upon 2 pi, integration of minus infinite to infinite x omega d omega. Again, this is the reverse property. So just I want to explain you how we can use this property in GATE exam. What does this mean? This means if you want to find out time domain signal at 0, it means right sided area, and most of the time one sided area easily you can find out, one sided signal area. So one sided signal area easily you can find. One example I want to tell you, del t Fourier transform is 1 and one Fourier transform is del t. What is this value at 0? Del 0 infinite. So this area will be equal to this value at 0. So del 0 is infinite. So area of 1 is infinite. Now here this value at 0 is 1. So here whole area is 1. So this value at 0 is equal to this area, and this area is equal to this value at 0. Similarly here, getting? Always you can, so if you can find out area of one sided, means second sided signal at the 0 value, easily you can find out. Always I suggest you, in every question you should try this property first. In every question always you should try this property first. Many time, at least if 4 options was given, 2 option will be 100% removed. Always you should try this area property. Clear this thing? So if one sided area you can find out, so second sided at 0 value easily you can find out, or at one sided 0 value easily you can find out, then second side area at least you can find out. So if one sided signal is not in curve shape, and if you can find out the area of one sided, so at least from the 4 options definitely you can remove 2 options. Clear this property? Now the last two properties remaining. Clear this? Now most important property I am going to take, most important property of the Fourier transform. All the property I am going to teach you, all the property. Okay, I am not going to leave any property. Okay, now the next property is the duality, and this is my favorite property, duality property. And many students cannot apply this property in very efficient way. If you are expert in this property, you can solve most of the question. What is the duality property? If a xt Fourier transform is xf, just B, then if this shape if I will put this shape here, So this shape just f will be converted into t. So this x just f will be converted into t. Then this Fourier then this step will become to here, and this will be nothing but x of, and this will be revert minus f. So just I want to tell you, if this Fourier transform you know, just use you can take this and just you can draw this. Just change f to t. Just change f to t, and this shape just you can put here and just change t to f, and signal should be reverted. Signal should be reverted. If this is a even signal, then this x minus f will be again x. Then don't worry. If this is an even signal, by one example I want to explain you. If this signal is given, suppose this is tau, sorry, this is tau by 2, this is minus tau by 2, this is 0, and this is a. Clear this thing? And this Fourier transform already you know. What is this Fourier transform? This Fourier transform is nothing but sync signal in this way. Sync signal in this way. And this is nothing but xf, and this is f. And what is this value? This value is a tau. This is 0. This value is 1 by tau. This value is minus 1 by tau. What you can write this mathematically? A tau sync f tau. Can I write? Now, what will be this Fourier transform? You can put here. So, what will be the value? A tau sync t tau. Only you should change f to t. F to t. So, this signal you can put here in time domain. Then this signal you can put in frequency domain. So, this Fourier transform will be the pulse signal. And this will be nothing but xf. And this is the even signal. So just you can put here and just you can revert. If this is the even signal, then this revert will be again same. So just you can put here, and this quantity will be tau by 2. This is minus tau by 2. This is 0. This is a. Just you can change this f. Only f. Nothing change. Clear? Nothing change. Clear the thing? Clear? This is very, very important. One thing you have to concentrate. Now I am going to take one example. Suppose, for example, this thing is given. This is 10. Suppose this is 2. This is minus 2 and this is 0. What is this Fourier transform? This Fourier transform 10 into 4. This is 4t sync and this is f into width is 4. This is 4f. You can write 4f like this. Can I write? Now, what will be the Fourier transform of 4t sync 4t? What is this Fourier transform? Is nothing but the same shape. This is 2, this is minus 2, this is 0, this is 10 and this is xf, and you can say this is f. What is the important point here? What generally student do? Student change this 2 to 1 by 2. Generally student will do this thing. They will do here this is 2, they will put here 1 by 2. You will get wrong. You have to concentrate on this. This is very, very important thing. So you don't change anything. Just you should think about here. This as it is you are going to shift here, and this as it is you are going to shift here. You are not going to change 1 by 2 to 2 or 2 to 1 by 2 anything. No, you don't change anything. Clear? This tau are the constant. This is the constant. And same constant will be reflected here. If this is tau by 2, this is tau by 2. Don't write 2 by tau. Clear the thing? Don't say, sir, this is time domain, this is frequency domain. So this will be 1 by. No. Just shape you have to change. So this shape as it is and this shape as it is. Only this shape you can put here and you should revert. Either this thing is revert or this thing is revert. Anyone will be reverted. Anything will be reverted. You can also write in this way. This is x of minus t. And this will be x of. Any side signal will be reverted. Clear this thing? Any side signal will be reverted. So just you should be clear. This pulse Fourier transform is sync and sync Fourier transform is pulse. Now, if I will say what is the Fourier transform of sync, directly you can write. Now, if I will say sync multiplication sync Fourier transform. Suppose, for example, clear this thing? Clear the duality property? Now, again, one important thing I want to tell you in terms of omega domain. So, always I suggest all the property except multiplication by t you should remember in frequency domain, and multiplication by t property you should remember in omega domain. Clear? But if you want to remember this property in omega domain, then what you will get? What you will get? Xt Fourier transform is x omega. Then you can put here. Then this capital X omega will be capital Xt, and this value will be here. And here you will get multiply by 2 pi. Multiply by 2 pi, and this is nothing but x of minus of omega. You can write in this way. You can write in this way. How you should remember this? You should remember by like this. Del T Fourier transform is 1, then 1 Fourier transform is del of minus f, and del of minus f is del of f. This is in frequency domain. This is in frequency domain. Can I write? In omega domain. So del T Fourier transform is 1, and if you are going to put 1 in omega domain already you know 1 Fourier transform 2 pi del omega. 2 pi del omega. So you can put here, and this multiply with 2 pi. This is minus omega, and minus omega will be written by 2 pi del of omega. Suppose if you forgot in GATE exam, how you should again recall this thing? By this, again you should remember, here 2 pi will be multiply or divide. Sometimes student get confused, 2 pi will be multiplied or 2 pi will be divided. What we have to put here? So just I am telling you, in most of the cases, just you have to use del. If you are getting confused between omega and f domain, if you are getting any confusion. Clear the thing? Okay. So I suggest you should remember f domain. Clear? Just this will be here, this will be here, and one sided will be reverted. If signal is even function, you don't think anything. Just you can put here and you can put here. Shape only you have to change. This shape will be here and this shape will be here. Only nothing. Clear? So can you solve like this? Clear this property? Clear this property? Okay. Okay, you are asking, sir, is there any way to get property in f domain? Just I am going to write each and every property in both the domain. Each and every property in both the domain. So just you can make a table and you should remember the property. Clear the thing? Okay. Now suppose here, if examiner will ask you this question, suppose sync multiplication sync, how to solve? So this sync, what is the Fourier transform? Sync Fourier transform is pulse, and this Fourier transform is pulse. Here pulse and pulse will be convolution, and you are expert in pulse convolution. Now here if sync convolution sync, then what is the Fourier transform? Here only 2 pulse will be multiplied. 2 pulse will be multiplied. If 2 pulse will multiply, what result you will get? Lesser width. If this width is 2 minus 2, if this width is 3 minus 3, what will be result? 2 minus 2. So if sync is multiplied, sync is convolution, easily you can solve. If pulse is multiplied, pulse is convolution, easily you can solve. Getting this thing? Now the next question. Here if pulse is multiplied, so first you can find out this multiplication and then Fourier transform. And here if I will say pulse is convolution, then how you can get? First this Fourier transform and this Fourier transform, and both will be multiplied. So here sync multiplication sync. This convolution you will get this answer. Can you solve? Left sided either sync multiplication sync convolution, or here pulse multiplication pulse convolution, or right sided similarly pulse multiplication or pulse convolution, or sync multiplication or sync convolution. So you should be expert in this all eight problem. You should try by yourself. Here sync multiplication, sync convolution, pulse multiplication, pulse convolution, and right sided pulse multiplication, pulse convolution, sync multiplication, and sync convolution. Clear this thing? I hope ki now you are expert in this. Clear? Okay. Yeah. Signal I will finish before 30. So you can expect till the 30, before 30 I will finish my signal as well as digital subjects. Clear this thing? One last property I want to tell you. One last property I want to tell you. All the property already I have teach you. One last and very again important property. Clear this thing? So you should be expert in duality. Always you should try area property first. Even and odd function you should try, and duality property you should try. These three properties are very important to solve most of the question. Clear? But some practice is required in Fourier transform. One last property. This is nothing but Parseval's energy theorem. Parseval is a scientist name. Parseval's energy theorem. This is energy theorem. Okay. So in previous classes already I tell you what is the total energy. What is the total energy of any signal? This is nothing but minus infinite to infinite mod of xt whole square dt in time domain, and this you have got from here. This is nothing but xt multiplication x conjugate t dt. And if you will solve this thing, you will get the thing. Already we have studied. And if signal is real signal, if signal is real, you can write in this way. You can write this is bracket x square t, or you can write in this way x square t dt. Already you know energy. Now, if Fourier transform is given, then what will be the energy formula? If a Fourier transform is given, sometime you cannot find out this area. First, you have to find out x square t, and then you have to find out area. Sometime we cannot find out as x square t and area in time domain. Then what we have to do? So you ask me the question, somebody asked me the question, sir, what is the energy of sinc function? So first you should find out Fourier transform of sinc function. Then you can apply this formula. Now I am going to tell you the formula. What is the energy formula? Same as it is. What is the total energy? Total energy integration from minus infinite to infinite, and most of the time Fourier transform is a complex quantity. So always you will use here mod of xf whole square df, because most of the time xf is complex quantity. So just you can write here mod of xf, nothing here xt, here xf. If omega is given, then 1 upon 2 pi integration of minus infinite to infinite x of omega whole square d omega. Clear this thing? Clear? So this is the energy formula. Now clear this thing. So integration xf whole square df. So if a time domain signal is given, and if you are not going to find out the Fourier transform, if you are not going to find out the energy very easily, just you can find out the Fourier transform and you can find out the energy. Clear? Suppose sinc function, suppose a sinc t. Suppose this function, you have to find out the energy of this signal. So first you have to find out this continuous time Fourier transform. What you will get? This pulse. And then you can get this pulse square. Very easily you can find out. So if I am going to tell you, this is a tau sinc f into t, tau into t. Suppose this thing is given. What is this Fourier transform? This Fourier transform is nothing but like this. Like this. This width is tau, this is tau by 2, this is minus tau by 2, and this is a, and this is nothing but xf, and this is f. Can I say what is this Fourier transform? A tau sinc f tau, and my duality property you can find out. So this sinc Fourier transform is this. Then what will be this energy? First you can find out x square f. X square f. What is the x square f? X square f you will get again tau by 2 minus tau by 2. This will be the a square, and this is f. So what will be the energy? Area of this x square f. So what will be this area? This area is energy. So what will be this signal energy? This signal energy is nothing but, you can easily find out from here, this is nothing but a square into tau. This is the answer. A square into tau, this is the answer. This is the energy of this signal. Why the sinc or any sampling function, if anything examiner will ask you, just you have to find out the Fourier transform. And then easily you can find out the energy. So generally energy, one question you will get in GATE exam. After 1-2 year, one question you will get from the energy. So just you have to think, time domain will be easier or frequency domain will be easier. Getting this thing? Okay. Now, you are asking, sir, can you please explain why we are taking conjugate there? So in my previous lecture, already I teach what is the conjugate exactly. And why we find out the conjugate? Why we find out the conjugate? Conjugate sometime why we find out? If you remember, if any signal xt is given and xt is a complex signal, so this can be break in two parts. X real part of t plus j x imaginary part of t. So sometime by trigonometric we cannot distribute or we cannot find out real part and imaginary part of the signal. So this x real part of t formula is you will get in terms of x conjugate t, and this x imaginary part of formula you will get in terms of x conjugate c. That's why sometime conjugate, to find out conjugate, you can say is very required. Okay, but in Fourier transform generally you will not get any question from this conjugate. Okay, so if you want to get very comfortable in conjugate part, just watch my previous lecture once. Okay, and just watch one, then you can ask me the doubt. Okay, in my Telegram group you can ask me the doubt. Okay, now any another doubt? Sir, that is for complex signal. For real signal you can ignore conjugate. Yes, if the signal is real. So one thing I also want to tell you, suppose if xt Fourier transform is xf, then x conjugate t Fourier transform is x conjugate of minus f. Clear the thing? Now if signal is real, so if a real signal, what you can say, xt is equal to x conjugate t, both will be same, then Fourier transform will be also same, then what you can say, xf should be equal to x conjugate of minus f. And again you can put conjugate both sided, what you can say, x conjugate f is equal to x of minus f. This thing you should remember. Again one more new property, this property also you should remember. If xt is a real signal, then its Fourier transform conjugate is equal to the reversal, then x conjugate f is equal to the x of minus f. Clearing in Fourier series also I teach you same thing. In Fourier series also I teach you this thing many times. So again you should remember this property, but this is valid only when xt is real. Clear this thing? When xt is real. Okay, getting? Duality also applicable in discrete time Fourier transform. I will tell you in discrete time Fourier transform. Just wait for this. Okay, now. Yeah, discrete time Fourier transform is not a tough thing. Discrete time Fourier transform only we will represent in terms of this. In continuous time Fourier transform, what we will represent? Either xf or x omega or x of j omega. But in discrete time Fourier transform, we will represent in this way, and in Z transform, we will represent in this way. So I will tell you in very easiest way. Just don't worry about this. Okay. So discrete time Fourier transform is not a very tough part. Okay. Just wait for my classes. Getting? Okay. So Telegram channel. Okay. I will share. Okay. I will share. Okay. So today class I am going to stop right now. Tomorrow again we will meet at same time. Clear? So tomorrow again we will meet at same time. Okay. You can ask any doubt in my Telegram. Okay. Telegram link I will share. Okay. Comment section of this today's video, in comment section you can find out. Clear this in comment section, not in this live chat section. In comment section you will get my Telegram channel link. Okay. I am going to stop today's session. Okay. Thank you and bye bye. Okay. Thank you.